So, I'm here today to talk about kind of a little journey that I've been on for the last 4 years or so now. And I'm going to start right back at the beginning. So around 4 years ago, I was doing some research, and I wanted to keep myself up to speed on kind of latest security standards, new browser features. And I came across this idea, this concept, where instead of the browser just being something that you render a website into and the user looks at it, the browser could actually call back home to you and tell you when things went wrong on the page, if the user saw error messages, if things weren't working properly. And I thought, wow, this is amazing. Like, instead of just sending the page off to the browser and saying, that's it, render the page, show it to the user, we actually start to get this kind of active feedback loop from the browser. And I was like, this is great. I really want to enable this on my blog. I want to put this on my website. So I spent a good 5 minutes looking on Google for a service that did this, and none existed. And if you spend 5 minutes looking for something on Google and don't find it, it definitely doesn't exist. So I was like, I'm going to build this tool. So I'd done software engineering at university, but I'd always used it as kind of a hobbyist thing. So I started up another little side project. I'm sure many of you have 100 little side projects at home like I do. And I started a little side project called Report URI. And it was a service that was designed to hook into these reporting features on the browser to start giving me this feedback. So 4 years ago, I started building it. It was about 3 years ago when I launched the first version. And nowadays, we're processing in the region of close to about 10 billion reports a month. So it's gone from quite literally a small side project where we literally, in our first month, did just over 10,000 reports, to now we have months when we regularly hit that per second. And this was just a side project. There was no plan, that I didn't have like grand visions. So I've had to learn a lot of lessons along the way to scale that. And I want to kind of go through those today and hope that I can share some of the value from that. So these reports themselves, they actually come from all mainstream browsers. Pretty much any modern browser that you have on your device is capable of giving you this feedback. And we'll talk about some of the feedback it can give you and how as well. But the number one thing that we kind of accept reports for is something called content security policy. So you may have seen me talk about this. I have plenty of blogs and information and material online. But when you enable one of these features on your website, you deliver the policy as a HTTP response header. So you have your web page, you have the other headers here that you may be familiar with, date, server, status, things like that. You set the content security policy header on your website, and in the value of the header that you send out, you put the policy you want enforcing. And a policy might look something kind of like this. So with CSP, what you do is you tell the browser what things it's allowed to load in the page, what things it's allowed to do. So here, for example, we have the script source. I'm telling the browser it's only allowed to load scripts from self, which means my own domain, and from this other domain, my CDN. I'm also telling it can only load styles from that location. Images can only be loaded from my own site, an imager. And the browser now knows this page is only supposed to use resources from these locations. And even the form action one's really cool if you've not seen that. You can control where the browser's allowed to send forms to. So it's not just about fetching resources, it's also about actions that the browser can take. Now, you deliver this policy and the browser will enforce it. It will make sure that your page doesn't do anything unexpected, anything bad. And if something does happen like that, the browser will actually step in and take action to prevent it. So it will block images from loading if the domain isn't whitelisted. If a form is trying to post data to an endpoint that's not whitelisted, the browser will prevent that. But we need the feedback. So you specify the last line here, which is the report URI directive. And if you specify this directive, you give the browser an endpoint where it should report back to. And every time a violation occurs, every time the browser takes action to protect someone or prevent something from happening, it will send you a HTTP post request with a JSON payload that looks a little bit like this. So you can set up an endpoint to receive this payload in, and this is what we do. We accept these payloads from visitors' browsers. And it contains all the information that you need to identify what the problem is and to go fix it. So we can see here the document URI. I know this happened, this violation occurred on the home page for my website. The violated directive tells me it was a script source, and it provides the snippet of the policy that was violated. The original policy, you always get that, so you can see what was the browser actually taking action on, so you have a reference point. And then the really important one as well, the blocked URI. So this is telling me you had this thing on your page, and in this case it was a script file called keylogger.js loading from evil.com. But evil.com wasn't in the script source directive, you can see a few lines up. So I've told the browser scripts should only be loaded from these locations on my site. Microphone. The browser has identified one. that has been loaded from a different domain. And it's blocked that, which is good because this would protect the user in this case, but then I wouldn't know as the host. So the browser's actually sent me this report back. We can ingest it, we can look at the information and now go fix the underlying problem as well. And it's not just content security policy and things like this the browser can report on. There's a whole bunch of additional features inside the browser where you can actually ask it to send you reports when things go wrong. Just plain things like the user sees an error message and can't load the site. Most of the time, you'd probably find out on Twitter, or maybe via an email or a support ticket. But what if the user hits an error and can't do something, and then the browser just calls home and tells you, so you don't have to wait for the support ticket or the email or for someone to tweet a screenshot of your broken website. It can actually get back in touch about a whole bunch of different things. So CSP is really good. One of the big uses that we're seeing right now, and I know another speaker is going to touch on this on Friday as well, is if you're migrating your site from HTTP to HTTPS, many of you have probably been through this or are going through this, you have this problem called mixed content. CSP can help you fix issues with your site. It's not just about security. HPKP, the second one here in orange, this is a bit of a risky proposition. I have an article about this. In fact, it's so risky that Chromium is intended to deprecate this feature, so it might not be around for very long. But the really good one in the top right in gray, certificate transparency. If you haven't heard of this, you should Google it and have a look. But there's essentially kind of mini search engines online where you can go search for your domain, and it will show you all of the certificates that have been issued for your site, so you can find ones that maybe didn't exist. But you're required to be compliant with what we call the CT policy for Chrome. So you get a certificate from your CA for your website. Most people generally don't know about this or come across it. But if that certificate is issued and you deliver it to Chrome browser and it doesn't comply with their policy, the browser will refuse to accept it, and the user will just get an error message on the screen. And again, you wouldn't normally know about that, but you can actually say to the browser, hey, if you go to my website and there's something broken and you're going to stop the user, please call back and tell me. I want to know about that before they have time to go and take screenshots on Twitter or send me emails. The XSS auditor is another fantastic one. So if you're not familiar with cross-site scripting, it's a super common attack. It's been in the OWASP top 10 since forever, and it involves an attacker trying to get JavaScript into your page that shouldn't be there. Now, the browsers have built-in defenses against this. Pretty much all mainstream browsers do. If they see an attack, or if the browser sees what it thinks is an attack against the visitor to your site, the browser will actually step in and try and mitigate that and automatically protect your visitor. And again, that's really good. We want the browser to do that, but wouldn't it be a lot better if we could find out if your browser of your visitor is having to take action to protect them on your site? We should really know about that because we probably have an underlying problem that we need to go fix again. And then last one, OCSP, is a performance and privacy feature that a lot of sites enable. And again, if you're enabling this and it's not working properly, then your users may see errors on your site. So all of these things are things that the browser can report on. We don't simply send the page to the browser anymore. It's becoming an active participant in the whole experience, in securing it, but not just security, functionality as well. So I wanted, all those years ago, to be able to accept these reports, and I couldn't find that service, so I built one. I spent about 9-10 months building it, and I launched it a little over 3 years ago. And going all the way back then, we had, or I should say, it was just me at the time, a rather simplistic view of the service and how it was going to operate. And I had no wild aspirations for it, so it was a fairly simple kind of little setup. Now, for probably sins committed in a previous life, I'm a PHP developer, so our whole application runs on a very basic Linux stack. We've got Ubuntu running 16.04, which is LTS, PHP 7.2 on top of Nginx, our web server. And we run all of that inside DigitalOcean. So DigitalOcean is just a VPS provider. They call them droplets. And we have a very kind of plain application stack there. But we were going to have a lot of storage requirements. We were going to be ingesting thousands of these reports. We needed to store them in a database. We needed to be able to query over them. And I'm not a database person. I have no database skills. And acknowledging this very early on, I also didn't want to go and learn how to be a good database person. So I have kind of this hybrid setup that many people kind of think is a little bit odd. We actually use Azure Table Storage as the back end for our database. If you're not familiar with table storage, it's simply just a key value store. You place an item in with a key, and then you can query it back out. So the reason we went with that I looked at a few other cloud providers, and I did consider Amazon's, I think it's DynamoDB they call it. And I look at the pricing structure and why we went with Azure, because it made a big impact for us. But this is all we run on. We have the application hosted in DigitalOcean, and it's backed up by Azure Table Storage for the database. Now, in our first month, we did 10,000 reports, and things started progressing very small steps, month after month. And of course, we're in the cloud. The reason we go to the cloud is that you can just dial things up to 11, right? It's like, we've got double the number of reports this month. We'll just throw some more cloud onto the pile, and then we can process all of these extra reports. The only problem with that is it also scales the cost pretty much linearly as well. Like, if we need double the resources, we're looking at essentially double the cost. And from our very first month of operation to our last month of operation, we're processing just close to 2 million times more traffic. So if we just literally scaled the cloud all the way up, we would have been looking at roughly 2 million times the amount of resources. So we had to get smart about this, and we've had to do several kind of really major iterations from that very simplistic first infrastructure. So this is how it first looked. We have the browsers. So these browsers are going to websites of our customers. They hit some kind of error message, and they post a JSON payload to us. They hit our servers. Our servers would then actually have to call into table storage to fetch the user entity, or the user's row, as we call it. We call them entities in table storage. So that would, A, confirm that a user exists with this account, and B, it would also pull back their filter settings. Now, the application servers at this point didn't maintain any state, so when the report came in, they fetched the user entity. We could then look at the report, do any custom filtering and processing, and then the application server would place it into table storage. Now, given how table storage works, if you've used it, you'll be familiar with the concept. We denormalize data on the way in. So we actually store each report in 4 different time slices so that we can query it back out faster later. In Azure, in table storage, it's cheaper to have multiple copies of the data for faster querying than a single copy and slower querying. So the service had to call in to see if the report existed in the time slice. It would then pull that back. If it failed, then we knew it didn't exist, and it would just insert it with a count of 1. If it returned the entity, it would increment the count and put it back. So for every single report that came in at this point in time, we were doing 9 transactions against Azure in table storage. Now, this wasn't really problematic at all for quite a while, because table storage is super cheap, and this is the reason that I chose table storage. They bill you on a flat fee per transaction against the database, compared to other providers where you had to provision a throughput of like 1,000 a second and pay for that whether or not you used it. Table storage is different. You can use 1 a second or 1,000,000 a second, and you just pay the per transaction fee. So we had predictable pricing with no wastage. And you can see here it was a fraction of a cent for every 10,000 transactions we did. So early on, I'm like, 9 transactions per report. This is no problem. It's like super, super cheap. We don't need to worry about this. But things started scaling, and my kind of really naive approach at the beginning didn't stand the test of time. So we've had to go through these kind of major iterations. And the first one was to give the application server some kind of state. So every time that report came in, we weren't constantly reaching back to Azure to pull back the user entity, because that was one of the first things that was really obviously wrong with this model. So we manage our whole fleet of servers with Ansible, so it was super easy to do this, a couple of lines of config, run the script, and we installed memcached onto all of the application servers that were doing report ingestion. And what this meant now was that we could start to keep things locally and memcached without having to go back to Azure into table storage for them every time. Now, the first and most obvious thing for us to do was the user entity. If the user exists and their filter settings exist, rather than querying them out of the database, we'll just keep them in memcached on here every time. So that was the first very basic step that we took, was to kind of make the application servers a bit smarter, give them memcached. And we managed to cut down the report to transaction ratio. We're down to 8 transactions per report now. And then about 2 years ago, we had just what we refer to as the incident, when we got hit by what wasn't actually a malicious attack at the time. So if you're familiar with the term DDoS, they're generally fairly malicious attacks. It's a distributed denial of service. Often somebody will go online to one of these services, they pay like $20, $30, and they essentially get like a whole botnet of computers, point them at your website, and just flood you with requests. The idea is to exhaust resources. Maybe it's bandwidth, memory, CPU, or whatever, but they are designed to make you unavailable by flooding you with too much traffic. And we got hit by something that we thought was a DDoS at the time, but was actually an accident. Somebody had deployed a policy onto their website, and I wrote this up, and the company, to their credit, allowed me to name them as well, because this was an accident. We were hit by an accidental DDoS attack. They deployed a policy on their site that accidentally blocked all of the resources on their pages. So for every single page load they had, they were sending us 20 to 30 reports for each one of the assets that were blocked. And then once you take that and put it onto a website that gets millions of visitors a day, we have several million visitors making 20 to 30 HTTP post requests with a big JSON payload on the bottom. And we just weren't ready for this back then. This was a very significant issue for us in many different ways. So the first one was that we just couldn't scale fast enough to cope. At the time, we only had 2 load balancers fronting up the whole service, and you can see here, they were pushing up towards 8,000 and 9,000 requests a second. The service started scaling, the 3rd load balancer had been added. At this point, it hadn't propagated in DNS yet because it wasn't getting any traffic, but by the time it had propagated in DNS, it literally got floored because the scale was still growing. So at this point, we're up to almost 10,000 requests per second on each load balancer, so the service trips over the next criteria, starts to scale again, deployed another load balancer, and as soon as that one was propagating in DNS, we were up to like 40,000 requests per second. And this just kept going and going and going. And I'm like, wow, the service literally can't scale fast enough on the time triggers to actually keep up with this. And we were starting to suffer really degraded service. And it actually got to the point where we literally just couldn't scale fast enough, so I gave up. And I was like, there's no point scaling because the traffic is outstripping our ability to scale. And also, we were up to like 50,000 requests a second on average per load balancer here. And this was just phenomenal. The metrics kept coming in and out because even New Relic, if you recognize the monitoring here, New Relic didn't have the resources on the servers to report back. But we were seeing over 700 megabits of inbound traffic per load balancer of just JSON data that we had to try and deal with. So we're coming up to 3 gigabits a second. And I'm desperately trying to figure out how to deal with this. How do you take that much traffic? You know, do we just go like, hey, here's 10 load balancers and quadruple the size of app servers? But I didn't have time because whilst all this was happening, an email came through. And the email came through from DigitalOcean, who are my hosting provider for the application servers. And they'd taken some steps along the way to try and mitigate the traffic, to break us off onto separate infrastructure because we were causing degradation of service. And then they actually just emailed us and said, we're just going to turn you off now. You're getting too much traffic. This inbound flood is causing a degradation on our service, and that's now having a knock-on effect. So they actually sent me this email, and I was like, oh man, I'm in so much trouble. Like, when your hosting provider gets in touch with you to say that they're dropping you, it's probably not going to be a great day. Now, one of the biggest problems that we had was that we couldn't stop the traffic. Like, how do you... Of course, I can try and get in touch with the company, because fortunately this wasn't hostile, it was accidental, so eventually they will turn this off and fix it. But in the interim time, we're still down. Our service was horribly degraded, and eventually our hosting provider turned us off and said they won't turn us back on until the traffic flood had stopped. And one of the biggest problems that we had was how we did the reporting. So up here are various different addresses. We've got our standard web application, the tools section, login, but the very top line here is the address that I would send reports to for my website. So every time somebody signed up, they got to choose like a vanity URL, /report/ something of your choosing. And then you would send your reports there. That is how we then filter them into your account, because we look at what we call the report token. So the report token links this address into your account. But the problem is, all of this was hitting the same infrastructure because it all resolved to the same host name. So when you resolve this IP, whether you're trying to go to the website and load a page or post a report, you're resolving to the same servers. So because we were being flooded with these reports and they were slamming our infrastructure, they were also killing our website because we couldn't isolate them. We can't filter on the path until it hits the application server. And by the time it hit the application server, it was literally already on fire, so we couldn't do anything about that. And this was like the first real light bulb moment for me, that the service hadn't been architected in perhaps the best way. And it only required a really simple change for us to fix this. And it was to take the report token from being in the path, which we can't do anything with until we hit the application layer, and drop it down to DNS. So we literally just took the report token from the path and moved it to a subdomain under the domain. So now all of our web traffic will hit the domains at the top, but the report traffic will go to their own unique individual subdomains. And this gave us so much control because this is a really powerful mechanism now, because it allows us to redirect and reroute traffic at DNS before it's even sent to us. Before it leaves the client, we can alter the flow of the traffic. So if we take a look here, our web application is now actually hosted on separate infrastructure, resolves to its own IP addresses, and that will now stop the same thing from ever happening again. We then have a wildcard subdomain, which will catch the rest of any random subdomain that someone can pick. So you can register and pick anything you want. It doesn't matter, it will be caught by this single wildcard subdomain. And then the really powerful thing on top of that is the ability to then actually stop traffic. Because if someone does this, someone misconfigures, or someone starts being hostile and flooding reports to a particular subdomain, we can now just kill a subdomain. So we can say this user's gone over quota, they've misconfigured, they're DDoSing us, essentially. We'll just null route their traffic. We'll resolve the subdomains of bad people to 127.0.0.1 and stop their reports hitting us. So we did this. And it was quite a big re-architect for us internally, and we also had to request all of our customers to change their reporting addresses from being in the path to being in the subdomain. But this gave us the control and the flexibility that we needed. We had to be able to protect ourselves. So we could now stop traffic at DNS, which meant we could stop it before it touched our infrastructure. Now, at the same time, one of the other things that we looked at was those 4 time slices as well. We allowed our users in the UI to query on the day, the hour, the week, and the month. And that meant that we had 2 requests into Azure per report for each one of those. So we also dropped a time slice. So we were still running on the infrastructure exactly like this, except now we were using DNS and subdomains to route traffic instead of a path. And by dropping the time slice as well, we were able to get down to 6 transactions per report. So this made us a lot more resilient. This reduced our costs quite a lot. But this still wasn't enough, because whilst all of this was happening over time, our traffic is just constantly ramping up. It's constantly growing, which meant that the costs are constantly growing. And this is a free service. I was running this as a side project. So we still needed to get smarter. We still needed to reduce our costs. The next thing that we did was then look at Redis. Running memcached on each server meant that we could avoid several calls into Azure. But one of the things that I noticed over time with these reports is that many of them are the same. So if you have an error on your website, and 100 different people go to the page and report the error, those 100 people are reporting on the same error. So the JSON payload is the same. We went to this page, this image is here that shouldn't be, these are the details. And all we were doing was constantly doing transactions in and out of Azure, increasing the count on how many times this error had occurred. Now we need to know the count, because the count is useful, because you want to know what's a big problem and what's a small problem. But constantly doing these increments was costing money in transactions into Azure. So we had to change that. We couldn't constantly have this one inbound report equals one set of transactions against the database, against table storage. We had to break that. And to do that, we switched from using memcached on each application instance to a centralized Redis server, which we still run now to this day. So we've now got this Redis server internally. The reports come in from the browser, and they hit our application servers. The application servers can store the user entity in Redis. They can store the filter settings in Redis. So they will process the JSON. They hold it against the strict schema set out in the specification. They do any filtering, and then they insert it into Redis. And we use Redis as a 10-second buffer. So all the reports that come in a 10-second period will buffer up in Redis. The consumer then sits behind Redis, and every 10 seconds will grab the contents of the Redis cache, pull them on board, and then start processing the transactions into Azure. And what this meant was, in that 10-second period, if we received 4,000 copies of the same report, because you're a really high traffic website, that report would be present once with a count of 4,000. And then the consumer could take that one report and just increment the count by 4,000 in table storage with a single transaction. And this was massive for us. The Redis cache is quite a powerful machine. It uses a lot of resources. It needs them. It has to be fast and highly available. But it allowed us to significantly change our report to transaction ratio. For every single inbound report now, we were only doing an average of 0.01 transactions into table storage. This was a significant shift to go from 6 to 1 to 1 to 0.01. So this was really good for us. The Redis cache held up for a long time, but I was still really concerned about that kind of DDoS scenario. yes, the Redis cache is good. Our application servers are now processing smaller and smaller loads. But what if that flood comes again? What if something like that happens? It could be accidental. It could be malicious. This is something that I guess every online service faces. And we needed to push this out to the edge. We had no protection on our outbound side. Like, we were the front line. Our servers were on the front line, and we needed to change that. And we did, because we brought on board a CDN provider. And the CDN provider that we chose was CLOUDFLARE. Now, most people understand the concept of a CDN provider. They sit in front of your website. They front your service. They will shield you from, obviously, hostile traffic, filter out DDoS attacks. So CLOUDFLARE do all of those things for us. But there's also a few more things that they can do. There's one thing that we've really started to leverage recently at CLOUDFLARE, and it's the concept of running code at the edge. So CLOUDFLARE have a feature called Workers. If you're in AWS, it's very similar to Lambda at Edge, and kind of like Azure Functions, where on an inbound request, rather than the CDN just kind of proxying that and then allowing it to pass through, we can now actually deploy code at the CDN's edge, and that code will be executed against each inbound request. And this is really good for us because a lot of what we were doing was very simple. It was holding JSON to a schema. It was filtering bad reports based on regexes. It was stuff that we were doing at scale that we could move upstream, that we could move away from our application servers. And the CDN's data centers are geographically distributed. We only have application servers in our one data center in San Francisco. So all the reports are sent all the way across the world, and then they may even be discarded because we didn't want them. They may be filtered. So now instead, by using CLOUDFLARE's Workers, we've deployed our filtering code into their, like, last week it was 150-something data centers. It grows every week, but they have them in all the countries around the world, which means the browser sends it to the local CDN, and then that CDN will run our code on that request. And the vast majority of the time, that results in the report being discarded for one of a number of reasons. So this is really efficient for the browser because it's only speaking to a local server, which means it can have the communication and close the connection. Everything's done a lot more quickly. And this is fantastic for us because by sitting them in the middle, we can prevent reports from hitting our origin servers as well. Now, the number one thing for us that CLOUDFLARE actually do is throwing away reports for people who have gone over quota. We have people sign up, especially on the free tier, and you get, let's say, 10,000 reports a month for free, or you pay for a larger amount. But once you've consumed your quota, we then don't process any new reports until the next billing month comes. But the problem is, if you run a service and you're on a model like that, if people keep sending you the reports, even if you're just discarding them, you've still got the bandwidth and the processing and everything else involved with that. So there's still actually a cost there. And this is becoming really kind of problematic for us because we're being flooded with all of these reports. They hit our application servers, we check the user account, and it's like, oh, they're over quota, just discard it. And that was a big cost at the time, especially for a service that has only just recently become commercialized because it was becoming so large. So CLOUDFLARE run this filtering code for us, and actually what I'm hoping to do, we may actually be able to get rid of this band of application servers in the end. We may actually be able to go from running code at CLOUDFLARE's edge straight into our Redis cache and just chop out the application servers in the middle by moving all of our code upstream and running it closer to the user's browser. Now, this is a big change for us. This was really good because it significantly reduced our costs even further, because now, for every single report that came into our infrastructure, we were only doing a fraction of a transaction against table storage. So we'd gone from doing 9 transactions into table storage per report down to 0.006 on average, which is a phenomenal saving, because we've gone from processing 10,000 reports in a month to an average of about 9,500 a second right now. And even as cheap as Azure table storage transactions are, that's still a lot of cost to build up over the period of a month. So as it stands right now today, this is what our infrastructure looks like. Our customers sign up, they deploy any security policies they want to onto their website, and the browser will come across them and dispatch a report. All of those reports, anytime you go to a website, will go to a data center local to you, where they will have our code at the edge run against them. We'll filter them, we'll hold them against a schema. We have some kind of internal filtering for spam reports, things that people don't want. But already, before it's even really traveled that far, this is where the vast majority of our traffic stops. because we can apply good logic and filtering to them at a location closest to wherever the browser is. If they make it through CLOUDFLARE to our application servers, there's a final set of processing that we do right now. And what we're trying to do is find a way to shift that upstream. And like I say, actually cut this band out. But we do our final processing, they go into Redis. And here is where we stack them for 10 seconds. Now, the one drawback of doing that, of course, was that 10-second window. This was something I was a bit hesitant about at the time, because previously, when a report came in, it essentially got processed straight through into table storage, which meant it would show up in your dashboard really quickly. But now, because of this 10-second buffer in Redis, it added 10 seconds to the amount of time it could show up. But looking at this and thinking about this, for the benefits that that brought, I didn't think that 10-second time period was too bad, because it allowed us to stack and deduplicate reports in an order of magnitude. So it did introduce a small time delay, but we can still get things through into the consumer and then into table storage, which means they will show up in your UI super, super quickly. That must have been funny. So that's our infrastructure today. That's the kind of journey that I've been on. None of this was planned for me. This was literally just a small project that I started. You know, I had the idea like 4 years ago. I built it 3 years ago. We only commercialized last year because it literally grew to the point where, despite the fact that we went through all these major iterations to try and make the service more efficient, it got to the point where when a side project is costing enough money that your wife gets mad at you, then you need to start thinking about whether I can keep running this as a side project anymore. So we took the choice to commercialize, and we did. But this is the journey that I went through. I want to kind of switch track a little bit now. That's how we got to where we are today. And of course, our core purpose is to provide that service to people, to ingest those reports and present them in a useful format. But a couple of interesting things happened in like the last year. And what we realized was, in isolation, a website's reports are fairly useful to them and them alone. I have a problem on my site, I get sent a report, and then I, as the host, can respond to that. But what we realized was that we had a slightly different view of the ecosystem as the host of this service. So we're currently processing, I say, it's like 8-point-something billion reports per month, and we have tens of thousands of websites that report through us. So at the higher level, we actually see a much broader view of the ecosystem. Now, when you run a service like this, one of the things that I will point out, if you do want to do this, when you run a reporting service like this, you're opening an endpoint to the internet and saying, hey, you can just post JSON data at me, and I will take it and put it in a database. Right? What's the first thing people are going to do with that? You're going to get all kinds of spam thrown at it. So it was about a year ago when it was like, okay, look, we need some kind of spam filtering. We're going to have to start working on this, because we do literally just stand up an endpoint open to the internet and allow people to post data at us that we ingest. So that's like a rife spam target. So I spent a little bit of time developing some basic spam filtering, looking at inbound reports, trying to discard them if they were obvious attempts to send poor data through. And one day, a set of reports triggered our spam system, and they were flagged up. We continue processing them until we decide what to do with them. And it's like, okay, these reports look like spam. Because what had happened is several thousand websites had all started sending the same report to us. And I was like, well, you know, what are the kind of the chances of that happening? All of these websites are all suddenly blocking the same thing. So I took a look at the reports, and the reports were coming in from literally locations all around the world. We were seeing this coming in. We see an average of about 78 million unique browsers every month, and thousands of them from all around the world were going to different websites, but blocking the exact same thing. And I'm like, right, okay, before we decide this is spam and actually start throwing these away, we need to be absolutely sure about this. So I take a look at the report, and they're blocking a JavaScript payload. And I was like, right, okay, so there's a script tag. According to these reports, there's a script tag on these hundreds of websites being visited by these thousands of people. And I was like, so how could all of these websites suddenly have a script tag in them that wasn't there 5 minutes ago, because we've seen the sudden influx of reports? I was like, this is starting to look a little bit spammy, and I'm not sure about this. But I did some investigation into the script tag. I grabbed a copy of it, I pulled it down, and had a look at what it was trying to do. And it turns out that it wasn't actually a problem on the websites, and the reports weren't spam. The reports were genuine. And what we'd realized was, by looking at the script payload, we found a reference to a Chrome extension inside the JavaScript payload that was being loaded on these sites. And that's kind of when it dawned on me. Like, so far, we'd been looking at this, like, the website has something bad on the page which is sent to the browser. But that's not the only way that something bad can get into the page? What if there's a proxy along the route that does something? Or what if there's a browser extension? Because browser extensions can manipulate the page. And it transpired that this browser extension had started to manipulate the pages of the browsers that it was installed on. So the browser would go to a legitimate, genuine website, except the browser extension had bad intentions. And it was injecting this JavaScript tag into the page. But these websites had CSP deployed. So the browser sees that script tag and says, well, this script tag isn't permitted. It would be blocked, and then it would dispatch the report to us. Now, if this user has this browser extension installed, and then they go to 10 different websites, they will trigger the same report on the 10 different websites, blocking the same thing. And this is what had kind of triggered our spam. And it wasn't actually spam. It was genuine. It just looked like spam. And we realized that this was actually really valuable information. So we're in a position now where we can see that this is happening, and we know this is happening, but there's no kind of reporting mechanism for this. Like for us, what do we do with this information? So fortunately, I have some contacts at Chrome, and I reached out to them and said, well, look, this is kind of a first. This thing triggered our spam, and it's not actually spam. We think it's a browser extension that's gone rogue. So I sent all the information over. I didn't hear anything for a few days, and then someone pointed out to me that the extension had been taken down from the store. And it was actually a browser extension that had gone rogue. It had turned hostile and was injecting script into the page. And we'd actually managed to detect that by accident. I won't claim credit for that, but we'd accidentally detected this. And then I thought, well, great, this is like a new feed of threat intelligence now. This is information that can't be had or found any other way. And as time went by, we had a couple of other little scenarios like this as well. The first of which was in a very large organization. And we actually managed to detect, again, kind of inadvertently, that they had malware on one of their internal endpoints. So a very big customer, they're using the reporting service, and they come to me one day and say, look, we get these reports, we triage them, we raise our internal tickets, and we fix the things, but we've got this one report that we just can't understand, and you keep sending it to us and telling us that we have it. And it was this one. So the site, you can see in the document URI, of course, I've altered the URL, but it was an internal intranet site. And they said any people that go to this are either on our internal network or are VPN'd into the office. This is literally an internal-only website. So if people are triggering this, we know this is coming from employees' computers. Okay? It's violating the script directive. They had their policy. And then looking at the block URI, it was literally just like a random jumble of letters on a Russian domain. And then the file was just called a.js. So you receive this report, the first thing that you do is go to this page on the internet site. And it's like, right, let's go find the script tag. The report says there's a script tag on this page loading from crazy Russian domain. And they're like, but we've had a look on the server, we've looked on the page, we've checked our logs, we've looked at everything, and there is absolutely nothing on the server that we can find that says there is a script tag on this page. So they spent all of this time kind of, again, looking at the server, and this was a traditional view, right? Like something in the page has come from the server into the browser, except it hadn't. By looking at the path and the pages that these reports were on, they managed to kind of garner a little bit of information about which department the person might be in, because they had different sections on their intranet site. And what they realized was the problem wasn't on the server. The problem was on the client. And in one of these departments, there were a couple of people who run legacy applications. And for those legacy applications, they needed administrative privileges locally. So they had local admin on this device, and with local admin, may have installed some things that they shouldn't have installed. And one of them came along with some malware. So they had some malware on the machine that was injecting the JavaScript into pages that they visited. And that was, again, triggering the CSP and sending the reports. So now we're aware of this endpoint. How do you find this, though? Because we don't have that kind of information available. Now, we did actually look at a few ways to do this by injecting random tokens into the path. But unfortunately, the company with knowledge of which department they were in managed to actually track down the user and sort out the endpoint before we got to deploy that. But we theorized a way that we could actually identify unique endpoints within a company using the CSP reports. So those are kind of two stories of how we've come to find ourselves in this position where we have information that we think that we can do more good with. Of course, we provide the service. That's the whole point of the service. But how can we use our position to help more people? Things like dropping browser extensions. Maybe you can identify malware on endpoints within your organization. they're not intended use cases of the technology, but they're really cool side effects. And there's a lot more stuff here like this you can do. So I wanted to wrap it up there and leave a good 10 or so minutes for some questions, because hopefully this might trigger some thoughts in people. Hopefully the lessons here may be useful for you in how you can scale and protect your infrastructure. But other than that, that's everything from me. Thank you. So, questions? Yes, wow, okay, let's start there.
You moved some code from CLOUDFLARE?
Yes.
To save on Azure, but I guess it costs money to move the code to CLOUDFLARE as well?
That's correct. So the question was, we moved some code from our origin into CLOUDFLARE to save on costs, but obviously there will be a cost involved in running code there. There is. The CLOUDFLARE workers, you start at a flat fee of, I think it's $5 a month, and that covers you for like 10 million requests, or 10 million executions of the code, sorry. And then you pay 50 cents per million after that. And by the time we'd factored in not only the CPU resources, but the bandwidth costs as well around our infrastructure, that is actually slightly more efficient. And it's also a lot more friendly to the browser resources, because we can terminate communications with the browser a lot sooner if we're closer to them. So yes, it does cost, but at least for us overall, it does work out cheaper. There's another one just there. So that's a great question, yes. So the question there was, I said that when a user goes over quota, we can now terminate the request at Cloudflare's edge, but how does Cloudflare know that the user is over quota? Is that accurate? So the awesome thing with workers is that it's not just a single piece of code that will execute on a request and then die. The workers can actually maintain state. They can actually maintain local variables over a series of executions. And if the worker is executed frequently enough, then it's never vacated from memory, which means that when the worker spins up and it gets an inbound report, it has a secure path to our origin to query the user's settings, and then it stores them in a local array. So then on subsequent inbound requests, the Cloudflare worker already knows, I've pulled back this user's settings and they're over quota, and all we do is flush that array on midnight when the billing month rolls. So the workers can actually maintain state across executions as well, which means the next thing that we're looking at, this is slightly into the future for us, is we're currently buffering those reports in the Redis cache. I'll show it you actually in context. So we're currently buffering those reports in the Redis cache. My current experiments, I'm testing this right now, is how many can we buffer in the worker? Because if the worker can maintain state and hold things in a local variable, maybe the worker could just buffer those up and dispatch them to our origin in batches as well. Now, I've started playing around with this. We're not actually doing this yet, but I think that's a really cool kind of concept, the ability to buffer up requests at the edge and then have them come in nice little batches onto our origin. Another question? Yes?
You often hear, like, don't do premature optimizations.
Mm-hmm.
Would you, like, was this a natural path, or did you wish that you optimized for scale at the beginning of the project?
So the question there was, sometimes people optimize too early, and do I wish that we'd done this earlier? Is that kind of fair? So all of our optimizations here really came out of necessity, largely because when I built the project, it was literally just a free spare time project. I thought this thing was cool, and rather than just build it for me, I'll open it up and anyone can use it. And then it was like, oh, wow, people are using it. You know, we need to change this, we need to scale. So literally all of these iterations came, for us at least, out of necessity. And ever since then, we've really been chasing to catch up, but it would actually be nice to get out ahead of that and start like planning and deploying infrastructure changes in front of the requirement. But you know, we're really small. Like I say, there's only 3 of us now. So yeah, it would be nice to start, maybe with the power of foresight, just planning a little bit further ahead would have been good.
Have you lost anything by not?
No, so we've never lost anything. The only real reason that we're making these advances is to save money, because they make the service more efficient. They drive down the cost, which means that it didn't cost me as much to run. So essentially, we've never actually thrown away reports. We've never lost reports. We've just paid more than I wanted to for the infrastructure. So it's a case of winding back that cost by making it more efficient like this. There's another one. Yes?
Do you end up with the same abilities as like a tracking cookie where you can see which browsers are going to which sites
Okay, so the question is, can we see that? Or so the question there is essentially, can we then see which browsers go to which sites? Was that right? And yes, the answer to that is yes. We are a security-focused service, so people deploy us onto their website. When their users go to their website, their users send reports to us. As a natural kind of part of that, we can see the client IP and the user agent because it makes a HTTP post. And then also the document URI in the reports we looked at is the page they're on. Now, our customers can take varying levels of control over that. Of course, we've got really strict privacy and security policies in place anyway. And just kind of like any service provider you bring on board, there's always a discussion around, are we comfortable in this environment? But there's actually ways that you can control that. So with Cloudflare Workers, we actually have customers that essentially proxy reports to us to shield the client IP and UA from us. And if you don't want to use the browser's native reporting mechanisms, we have a JavaScript library that you can drop in. And that actually builds the report payload for you, which then allows you to filter information on the client before it gets dispatched to us. So these are things as we grew, these are things that we came across, problems that we came across, and we've built the solutions to them as we've gone. Try this side. Questions? No, they decided not. Any more on this side? I can't really see, so if you've got your hand up, just yell. No? All right, well, that'll be... Oh, there's one. Yes, there you are. Sorry, I did see one.
Oh, I basically got the answer from the last guy here, but you are the normal user, and the user is the website owner and not the end user.
Mm-hmm.
Of course, yeah.
So yeah, I guess it's like...
The user field on top of it,
Yeah, so I guess there's like multiple overlapping definitions of the word user. So we have our users who would be the website operator, and then they would deploy the report or the content security policy onto their website, and then their users would trigger it and send the report to us. So yes, depends which user you're talking about, but yeah, there are multiple definitions of the term. Were there any more? Yes, there it was. Shout louder, sorry. So if you were visiting one of our customers' websites, how would you not send information to us? I guess that's kind of a tough one, because in visiting... So the question, sorry, just to clarify for everyone, was if the gentleman went to one of our customers' websites and ended up sending a report to us, could you opt out of that or prevent that in some way? I guess by going to their website, you're participating in their delivery of the service of their website. So they may have a CDN provider, a database provider like us. They will have the people and the companies that they've chosen to bring into that. And your browser will send that automatically in the background. So if the site you're visiting has chosen to do that, and I guess this is the key point here, this is part of the service delivery that they have chosen to build. So right now, I don't know if there's a way to turn this off in browsers. It's an automatic reporting mechanism that runs in the background. Yes. Oh, sorry. Yes, this one.
You can also have the CSP test.
Yes.
So can you utilize the test part to build a good security policy for your website?
Yeah, so that's a really good question. Content security policy is very powerful, so if you deploy it wrong and you block all of your style sheets, you have no style sheets, as you point out. So there is a test-only mode for CSP where you can deploy what you believe is your correct policy, ask the browser to send the reports, but don't actually block anything. So if the policy is wrong, it won't harm or damage your website, but you will still get the reports back to say, this thing we've missed out, we'll go add it to our policy, and now the policy is correct, and then you can enforce it. So you can deploy these things safely and securely without any risk to actually damaging the user experience on your site.
You release your code for this. Can I set up the backend for this?
No, so the project itself isn't open source. We do have various bits of code and tools and things like our Cloudflare worker, we released the code for that. I've started publishing our Ansible configurations, but the actual kind of core product itself isn't open source, no. Any more questions? All right, no, I think we're good. Thank you very much.